friends, welcome to my channel Maths Academy by DG. Today we are going to continue the IT of inverse trigonometric functions and chapter number 2, lecture number 5. Yes, I have completed total 4 lectures in this chapter and now already I have started exercise 2.1. Yes, so some problems already completed. Suppose if you are not subscribed to my channel still, please subscribe to my channel and give the thumbs up. Yes, and share to your friends also. So see the question number 8. Already I have completed 1 to 7 questions. Find the principal value of the following. Question number 8 having here cot inverse root 3. Yes. So by taking the cot inverse root 3, first we have to say let cot inverse root 3 is equal to y. Yes. We are taking the cot inverse root 3 is equal to y. Suppose from this we can write what cot y is equal to root 3. Yes or no? By writing the cot y is equal to root 3, after this what we have to write, we know that, suppose if you don't know anything also you have to say we know that. Yes, what do you know that? Now I will write, we know that the range of principal value branch of which one? See this trigonometric inverse trigonometric function, that is cot. Yes, cot inverse. Cot inverse. Yes or no? Just I will write here of cot inverse is, what is that? So you people have to know this. Open interval 0 to pi. Yes, cot inverse range is 0 open interval 0 to pi. Cos inverse is close interval 0 to pi. That's all. Okay. So next, see cot y is equal to root 3. In cot, when we can have the value, in which angle we are having the root 3? At pi by 6. Cot 60 or cot 30 this? Yes sir, this is the cot 30. At cot 30 we are having the value is root 3. So from this we know that from the trigonometric equations cot x equal to cot y means x is equal to y, like that y is equal to pi by 6. Yes or no? So having the pi by 6, after having the pi by 6, just we have to check whether it is in this interval or not. Yes sir. So therefore we can write the answer. The principal value of cot inverse root 3 is, what is that? Pi by 6. Yes. So this is the answer. We can see the next question having here. So now by observing this question again, whatever the inverse trigonometric function is there na, so we have to take as a y first. So I am writing cos inverse minus 1 by root 3 is equal to y. So now from this, by sending cos inverse on right hand side, cos y is equal to minus 1 by root 3. Suppose having the minus, there is a small confusion will be get. Yes. So what is that means? First we have to check. Sir, cos is negative. Yes sir, cos is negative. Which quadrant cos is negative? Second and third. Yes or no? So that's why we can write here cos y is equal to. So what we can write cos y is equal to cos of. In second quadrant angle is pi minus theta. Suppose cos, cot, sec. These three inverse trigonometric functions giving the value is negative. Remember we have to take pi minus, that's all. Okay. So pi minus theta. Theta is nothing but, check, 1 by root 2. 1 by root 2 in cos pi by 4. We have to theta is nothing but pi by 4. Yes, it is very easy now. So cos y is equal to, we are having cos 3 pi by 4. Now we are right. We know that again same dialog you people have to use here. Yes, this dialog only I am using. We know that the range of principal value branch of which one? Cos inverse is, what is that? Close interval 0 to pi. Remember, for cot we are taking open interval 0 to pi. For cos we are taking close interval 0 to pi. Next, cos y is equal to, cos y is equal to cos 3 pi by 4 sir. Next, y is equal to what? 3 pi by 4. But what is 3 pi, value of the 3 pi degrees? That is what? 3 into 45. 3 into 45 is 135. 135 which is in between 0 to 180 or not? Yes sir, which is in between 0 to 180. So we can say therefore the principal value of which one? Cos inverse minus 1 by root 2 is answer 3 pi by 4. This is the answer. Yes, it is a very easy now. So we will see the next question. See, this is the question number 11. So you people have to complete the question number 10. That is a very simple one. Yes. So see the question number 11. In this 1, 2, 3 inverse trigonometric functions are there. Yes. But it is a very simple. In only one step we can complete. When it is possible means actually the properties of inverse trigonometric function will be there. That is the next concept after completion of the exercise 2.1. We are going to start the properties of inverse trigonometric function. So there are some properties are having. So which property? I will write C. Sin inverse x plus cos inverse x is equal to, what is that? Pi by 2. Yes. So see here, x is nothing but two angles should be equal. Yes, two values should be equal, not angle. This is the value here. So two values should be equal. So the minus 1 by 2 minus 1 by 2, both the inverse trigonometric functions having the same value or not. So that's why we can write directly this total result is here pi by 2. But still I have not completed the properties. That's why we can continue whatever the concept we are doing in the first exercise. I will apply that. See, for the first part we are going to say x and this is y, this is z. Yes. So I will write here tan inverse of 1 is equal to x, and from this tan x is equal to 1. Yes or no? So after that tan x is equal to, when we can have the value is means 1 at pi by 4. So finally we got the x value from this, x is equal to pi by 4. Yes, completed now. So this is the x. After that we have to take the next one. Cos inverse of minus 1 by 2 is equal to y. By setting on right hand side, cos y is equal to minus 1 by 2. We know that suppose the cos is negative, just now we have completed. So immediately we have to go in the quadrant system, second and third quadrant having the cos is negative. In the second quadrant pi minus theta. So I will write here cos y is equal to cos of pi minus theta is nothing but 1 by 2. When we can have the 1 by 2 at pi by 3. Cos 60 is 1 by 2. Next the y value will be here cos y is equal to cos, by taking the LCM it will be what 2 pi by 3. Yes or no? So value is y value 2 pi by 3. Now immediately we are taking the last one, that is sin inverse of minus 1 by 2 is equal to z. So from this sin z is equal to minus 1 by 2. Yes. So sin is negative. If the sin, tan, cosec, three trigonometric functions having the negative, we are having the negative value. So no need to get the confusion, because of in the range of the inverse trigonometric function having the negative angles also. Yes or no? Suppose observing the range of the inverse trigonometric function sin inverse. So which is between what? Minus pi by 2 to pi by 2. So in that having the negative sign angles also. So that's why. So just I will write sin z is equal to sin of what we can write? Minus pi by 6. Yes or no? Sin of minus theta is minus sin theta. So minus sin pi by 6 is 1 by 2. Yes, that's why we are getting minus 1 by 2. So z value is minus pi by 6. Yes. So now see here, first we have to write this as a in the solution. So actually it is what? X plus, this one is y, this is what? Z is equal to, write the question mark and say the equation number 1. Yes, substitute x comma y comma z values in equation number 1. So 1 implies that I will write here x is nothing but what? Pi by 4. So x plus y plus z is equal to, x is pi by 4 and y is 2 pi by 3 and z is minus pi by 6. Suppose we are taking the LCM, that will be the 12. So 12 by 4 it is 3. So 3 pi. Again 3 here 12 means 12 by 3 is 4. 4 to the 8 pi minus 12 by 6 is 2. So we are having 2 pi. Now finally the result of this one will be LCM. So it is actually 11 or not? 11 pi minus 2 pi by 12 and next one is 9 pi by 12 gets cancelled 3 times, 4 times. So finally we got the 3 pi by 4 is the answer. Okay. So this is the process we are doing here, but there are some properties of the inverse trigonometric functions in front of the exercise 2.2. So suppose you people know already the properties of the inverse trigonometric functions, immediately you can also apply the answer. See, suppose by applying the properties, how we can make the answer means the first one is tan inverse of 1 can be written as tan pi by 4 and next one is directly pi by 2. Yes, there is one of the formula. This formula, which one? Just now I wrote na. Sin inverse x plus cos inverse x is equal to pi by 2, and tan inverse of 1 is nothing but tan 45 pi by 4. Tan inverse of tan, again there is one more property. We can write pi by 4 plus pi by 2. By taking the LCM 4, so pi plus this is the 2 pi. Yes, finally we got the 3 pi by 4. Only two steps will be left in. Just we are going to continue in this by using the properties. Yes, you can do by using the properties, or if without using the properties also we can do like this. Yes, there are two methods are having to complete the exercise 2.1. Yes, no need to get the confusion. So we can see the next question. See the question number 13. So question number 13 and 14. Okay, after the 14 our exercise will be complete, exercise 2.1. If sin inverse x, this is actually sin inverse, okay, sin inverse x is equal to y, then okay, sin inverse x is equal to y is nothing but what is y here? Actually it should be a range of the inverse trigonometric function. Yes or no? So we know that the range of the inverse trigonometric function is minus pi by 2 to pi by 2, close interval. So close interval, so suppose we can write y belongs to, this can be written as minus pi by 2 less than or equal to, because of close interval, y less than or equal to pi by 2. See which option is the correct one. So second option is correct now. Yes. So now see the question number 14 here. This is the last question in this exercise. Tan inverse root 3 is there now. So tan inverse root 3, one more value is secant inverse of minus 2. Yes. So we know that for the tan inverse root 3, I will write here again x and this is y. Yes or no? So by taking this, tan inverse say x minus y is equal to question mark, and equation number 1, tan inverse root 3 is equal to, we are writing x, not tan x is equal to root 3. Sir, we know that already root 3 is nothing but tan pi by 3. Yes or no? We got the x value is pi by 3. Completed. So sir, they are very simple questions. Yes or no? And one more thing here, secant inverse minus 2 is equal to, we are writing there what? Y. Yes or no? So by writing this, secant y is equal to, I will write here minus 2. So now see, suppose we got the cos, cot, sec, negative sign, definitely we have to check again where which quadrant secant is negative. Second quadrant, that's why I am writing here secant of pi minus. Now when we are having the value is 2 at pi by 3, yes, because of cos 60 is 1 by 2, reciprocal of that is we will get here. So finally secant y is equal to, I got here secant of 2 pi by 3. Now the y value is 2 pi by 3. Yes sir. So we got the x value and y value. So x minus y is equal to, from the equation number 1, just I will write here. All of you able to see here. So now x minus y, from equation number 1 implies that x minus y is equal to pi by 3 minus, I will write 2 pi by 3. Yes. So by taking the LCM 3, it will be minus pi. See which option having the minus pi by 3? That is again second option. Okay. So up to here we have completed the exercise 2.1, and students, if you are not completed the exercise 2.1, remaining question, homework question also please complete, and once you have to see the what are the question you people having the doubt, and still you are feeling sir there is a doubt, so please make a comment. Okay, thank you.